Good morning. So we're going to take a look at Kubernetes, and specifically we're going to take a look how to take containers to production, because that's, to my opinion at least, where containers really shine. Sure, a lot of people use Docker in development environments, and it's useful there. But it becomes so much more useful once you actually start to do production deployments using containers, and we will very quickly see if you start doing that, you need a little bit more than just Docker or whatever container technology, and you need something like Kubernetes. But even with just Kubernetes, we are not quite there yet. That's just a tool. And to be able to use such a tool successfully, well, we have to configure it and set it up in such a way that you get all those things like automated deployments and failover and auto-scaling and stuff like that. So that's what we're going to talk about. So why am I talking about this? If you have been at JDD before, you might have seen me talking about OSGI. That's still the technology that I work with a lot. It's still technology that I love. And most of the projects that we run in the company that I work for, Luminous, is being built with OSGI. Well, that's great. That's the way we build things. But then once we want to go to production, well, you have to deploy stuff and you have to automate that. And in recent projects, I gained quite a lot of experience with that. So we had some quite large deployments running on Amazon, all automated completely. And we were very happy with those approaches. The problem with those approaches were that it was pretty difficult to actually carry that over to new projects. So we had all this automation going on for one project, but then we had the next project, and well, we kind of had to start over from scratch. And that meant that, well, it was expensive and time consuming to actually set up such fancy production deployments. So about 8 months ago, I started a team to actually work on what we call the Cloud RTI. That's our runtime infrastructure to run containers in the cloud in a, well, easier way, so to speak. So all our teams are now running on this infrastructure, and that's, well, basically how I got started with Docker and Kubernetes, etc. So I'm not going into the details of the product itself, but more about all the concepts that we learned about. So what we're going to do in this talk is we're going to take a look at Kubernetes, and we're going to look at 7 different steps that brings you from Kubernetes to actually a production-ready environment based on Kubernetes. Because as I said, Kubernetes is just a building block, it's just a tool, and it's not something that really, well, works very well out of the box. It's not meant to be working out of the box because it is just a tool. So we have to add some work to that ourselves. But before we start looking at those 7 steps, let's actually understand a little bit better how Kubernetes works internally. I assume not everyone is using Kubernetes on a daily basis yet. So let's explain Kubernetes a little bit, see how the different concepts that we have there work and how they are named. And based on that terminology, we can actually, well, look around the tools around it to actually make it a production-ready environment. So maybe even before we start looking at those concepts, why would you be using Kubernetes in the first place? I'm sure everyone heard about Docker and what containers can do for you. And one of the really nice things about this whole concept is that you can package up something on your development machine, you can test it that way, etc. And then you can take that exact same image and bring that all the way through to acceptance and production and all the environments that you have. That's great. But if you look at well, how Docker works, Docker is mostly running about a single container or multiple containers on a single host. Well, that's okay-ish for development, but most of the time when we go to production, we have multiple nodes. We might have 10, 20, 30 servers that we have to use and that have to deploy to. And our software should be replicated over those 30 machines that we have. If you just have Docker, well, you would have to Docker run on every machine, which is of course not very feasible, and you don't get anything like automated failover or stuff like that. So that's really not enough. That's where Kubernetes comes in. So Kubernetes is a tool to actually run containers in clusters, and it's really good at that. And Kubernetes is quite a new project. It just started 2 years ago or so. But it's actually built on top of all the ideas from the Google Borg paper. And if you don't know what Google Borg is, that's actually Google's infrastructure, how they have been running their infrastructure for many years already. So there's a lot of experience, of course, from those teams, because they definitely ran at scale. There's a lot of experience there, and then they decided to kind of carry over this experience that they have, start a new project to make this, well, these ideas available to the rest of the world. So Google is one of the big contributors to the project, and Red Hat is one of the other very big ones, and there are many others. So the project is hosted on GitHub. You can see the source code, etc., and it's a very active project as well. And well, it goes, the development goes very fast. Okay, so we want to use Kubernetes. So let's understand it a little bit better. If you have Kubernetes, there's 4 concepts that you should know about, and we start with the first 3. So if you have Kubernetes, you have a Kubernetes master, and the Kubernetes master kind of controls the whole cluster. The master doesn't really do much work. That's just where the API server runs, and it controls the rest of the cluster. The place where your containers actually run are on the Kubernetes nodes. So the Kubernetes nodes are the actual servers where the containers are deployed and run. And if we deploy a container, a Docker container, we deploy them as a concept of a pod. A pod can actually be multiple containers deployed together, but let's say a pod is a container, right? So it is a container with some extra configuration like ports and stuff like that. If you want to actually start such a pod, so if you want to run a container in Kubernetes, you basically have to create a replication controller on the master. And a replication controller is kind of the description of how you want to run your container in a cluster. So you say, well, I have this container with an image that I have, and I want to replicate it on 5 machines. And that means that the replication controller will actually spin up pods on 5 different nodes and make sure that those keep running. If one of those 5 pods crash for some reason, maybe your application goes out of memory and it just gives up and quits, it will start a new one on a new node and make sure that, well, you kind of keep those 5 replicas running. So that's the first concept that we have. Then there's one more concept, and that's the concept of services. So if you look at Kubernetes, each container that we start gets its own virtual IP address. So you're not hosting containers directly on the IP address of the host machine, but all of them get their own virtual IP on a virtual network. And this is really nice because that way, well, every container that you deploy could run on port 8080, for example, which will not conflict with each other because all the containers have their own virtual IP address anyway, so they can use port 8080 if they want to. The problem with this approach is that, well, those virtual IP addresses are kind of, well, generated. If you deploy a container in Kubernetes, you never know what the IP address will be. So if you have, let's say, a microservices architecture where you have multiple components talking to each other over the network, well, how can they actually communicate to each other because they don't know where the other pods are. They don't know the IP addresses because, well, those are dynamic. So then we have the concept of services, and a service is basically a proxy. So this service gets a fixed IP address within Kubernetes, which will not change. And if you want to use such a service, it will just proxy or route the traffic through one of the or to one of the containers that I have running on one of my nodes. So that way you have kind of a transparent way to communicate with pods while you don't want to know about the exact location of those pods. And this is important as well if you do intra-service communication within your Kubernetes cluster. So these are kind of the basic concepts that you will run into when working with Kubernetes. So let's start deploying something. And we didn't automate anything yet, so we're just using the basic tools that Kubernetes gives us. And it basically means that we have to push our Docker container to some kind of Docker registry, let's say the Docker hub. The next thing that we need is to create a definition of our replication controller. Remember, that's the thing that will actually spin up the pods on the different nodes that we have. Given this JSON file that we have, we can use the kubectl, the kube control tool, that's a command line tool we get with Kubernetes, to start everything up, to start a deployment. The replication controller will be created on the master, and on its turn, that will create the pods on the different nodes that we have. Well, okay, that's kind of okay-ish. And just to give you an idea, this is a JSON file that describes such a replication controller. The important parts are in the spec at the bottom. You say, well, I have some kind of container which is hosted in some kind of Docker registry, and it exposes, in this case, port 80, right? So that's the definition of a replication controller. Well, that works. Containers will start up, they will start doing work, and then I can do things like scaling. So once again, I can use kubectl scale, give it a number of replicas, and it will spin up new pods in this case, giving me more replicas of the same container that I already had running. Looks pretty cool, but still it doesn't feel very automated. Then I want to update my app. So I made some code changes and I want to deploy this new version to my cluster. And here it starts to be very hairy because, well, I have to create a new replication controller file because a replication controller only creates stuff. It will never delete running pods. So that means I have to create this new JSON file containing probably the new version of my Docker container. Once again, I have to go to kubectl create to actually spin this up. And then I manually have to scale down the old cluster. And hopefully I do that in a way that I don't cause any downtime. Doesn't feel very automated at all. This is not what we want, right? I mean, today you probably deploy to production many times, for some people maybe a day even. And it's just not acceptable if that could cause downtime every time we deploy. That's something from the older days. So we can conclude that out of the box, well, Kubernetes is just missing some parts. This kubectl tool is useful, but it's just not enough automation. So let's start automating things. The first thing that you really have to learn about using Kubernetes in a more reliable way is that this kubectl tool, that's nice during development and maybe for some simple administration tasks, but besides that you really want to use a Kubernetes API. And everything in Kubernetes is exposed by its REST API, and that means, well, that's the thing that you're going to talk to. You're going to write your own tools that talk to this REST API. You will find other tools written by others, we'll point out a few later, that talk to this REST API. There's client APIs in different languages, including Java, to talk to this API. So that's the way you actually automate things and make Kubernetes part of a larger deployment pipeline. So what we're going to do is we're going to use this API to let our build server start a deployment. So the build server will trigger a REST call that will actually create this replication controller. And from there, we have our first automation going. Of course, it's still simple. But let's say we have a Bamboo server or a whatever other build server that we have. And we simply start a curl to the REST API of Kubernetes, right? And we just instruct that we want to create a replication controller, and Kubernetes will take care of the rest. And that could be as simple as just literally a post to a endpoint address. And here we say, well, we want to create a replication controller, and in the pod definition part, we will just paste the JSON that we previously had in the JSON file that we wrote for the command line tool. So this is better. At least I don't have to type everything myself every time. At least there's some automation. But we're not quite there yet because, well, what about downtime? If we deploy this way, how does my load balancer know, for example, when to switch to the new version that we just deployed? well, there's no concept of a load balancer in the first place in the scenario that we have here. So there is probably just going to be scheduled maintenance or unscheduled maintenance. So we're not quite there yet, but we made a first step. So with this first step, we got our containers running in the cluster. And probably we want to access them, right? So let's assume that we wrote some kind of web application. And this web application is going to run on multiple pods in my cluster. But of course, I have to be able to access those, this application using a web browser, because that's the whole idea of a web application. So if you look at Kubernetes, there is not really a concept of a load balancer. And there is a good reason for that. Because Kubernetes is designed to be able to work in different kind of environments. So there's different cloud environments that support it. For example, the Google Cloud Engine offering is built on top of Kubernetes. Well, they have load balancing. You can run it on your own hardware. Well, then you might have your own load balancer. But, well, Kubernetes, of course, doesn't know what kind of load balancer that is. So out of the box, there is not really load balancing functionality. And I'm, of course, talking about HTTP load balancing. There is no load balancing functionality in Kubernetes. So we have to add that ourselves. So you could use whatever proxy you like, but the one we settled with is HA proxy because it's very reliable and open source. And we will just run HA proxy as you would normally do on a separate machine. So we have one or more machines just running HA proxy, taking care of things like SSL offloading, etc. Our HA proxy will then route all the HTTP traffic to one of the containers that actually run our application backend, right? Because we specified that we might want to have 5 different replicas of this application. So we just have to route traffic to one of those 5 containers. I will get into the question how we can actually figure out to which containers to route. But what we basically do is that of course, HA proxy needs to be reconfigured, basically, every time that a container starts up. Because, well, you need to configure a new backend, for example. So what we did is we hooked up HA proxy to a tool called confd, which is actually a very small tool that can generate configuration files based on information that we have in etcd or other key value stores. So why I'm suddenly talking about etcd? Well, etcd is one of the key value stores which is very usable, and Kubernetes already relies on etcd. So if you run Kubernetes, you also run etcd. So we can easily use that for our own configuration as well. So we basically look using confd in etcd for certain keys that we have. And based on that, we generate new configuration files for HA proxy, reload them on the fly, and we have our new configuration running on the cluster without any kind of downtime. So this is the first thing you have to get into place to even see your application running in a Kubernetes cluster. To actually get this working, well, we have to think about something else, because in this picture, you see there's a line from HA proxy to the Docker containers. But I just talked about the fact that if you run containers in Kubernetes, they will get their virtual IP. Those virtual IPs only exist within a Kubernetes cluster. That means if you have another machine running HA proxy, which is not actually part of the Kubernetes cluster itself, because it's not a Kubernetes node, well, it will actually not be able to see those virtual IP addresses. If you try to access those just don't exist on your network. So that's a problem. But Kubernetes is built in such a way that you can hook into the whole networking layer, and you can plug in some kind of virtual networking or software-defined network tool, and there are several of them. So for example, we could use something like Flannel, which is a SDN provided by CoreOS. And that way we can also access those IP addresses which are virtual from the other servers that we have in the cluster. So we have our HA proxy server running, and we kind of just put a Flannel network on top of our network, Kubernetes will automatically start using those, or start using that Flannel network, that virtual network, to create those virtual IP addresses. But now those virtual IP addresses are accessible to other machines in the Flannel network. So you have to learn about SDN a little bit, which well can be a little bit overwhelming if you have never done that before. It was a bit overwhelming to me, to be honest. But actually it's not that difficult, and it's an important step to well use Kubernetes in the bigger picture. So we have a lot of options if you start looking at SDN. We currently use Flannel because it's very easy to run and set up on CoreOS, and that's what we use. Weave is another nice option which has a lot of features. The problem with Weave is that it's currently kind of slow. That's because it runs in user space, and that means there's some extra overhead going on. If that's a problem, that entirely depends on your situation, of course. And then we're looking at another very interesting project, which is Project Calico, which is kind of a new solution, but they promise deep integration with Kubernetes. And actually they have lots of examples working already. And what they, for example, have is the possibility to create completely separated networks for different namespaces within Kubernetes if you have a multi-tenant setup. So if you have multiple customers running on the same Kubernetes cluster, you can completely separate their networks, which is very useful. And of course, if you know about the new features in Docker, there's a lib network there, which means that in Docker itself, there's a lot going on if you talk about networking, which will end up in Kubernetes sooner or later as well. Okay, so we now have the possibility to run HA proxy as a load balancer. HA proxy is able to access our pods because we have this Flannel network. That's good. But how does the load balancer keep track of pods? Because every time I scale, for example, maybe with some auto-scaling algorithm that we use, new pods might be spinning up, or maybe pods crash and they're rescheduled to other machines. So pods kind of come and go, at will almost. And Kubernetes doesn't give much guarantees on which machine, for example, a pod will be started. And that's something you really don't want to know about either. So that does bring the question, how does my load balancer keep track of those pods? How do we actually know where to find them? So this is something that you probably have to write yourself. And there's some different open source tools available, including the one that I'm going to talk about right now. So we wrote a tool which we call the Cloud RTI deployer. So this is just a tool that runs in your Kubernetes cluster, and it kind of communicates with a Kubernetes API, and it watches for any new pods. So every time something changes in the Kubernetes cluster, the deployer tool or the component is notified about that. This tool will then go to etcd and set up some new configuration for HA proxy. So it will configure new backends basically for HA proxy to use. Confd is monitoring etcd on its turn. That's just a tool that's also open source. And it will reconfigure HA proxy to start using the new backends, or to stop using backends if some backends disappeared. So you see there's a lot of different components going on here. We have, this deployer tool that we have etcd, we have confd, and that's kind of the world you have to, get familiar with if you start using Kubernetes for real. There's lots of different tools available. Most of the time they're really small tools. They just do, one thing and that's it, which is good. But that means there's a lot of different small components in your whole deployment architecture. It's not just Kubernetes. So this deployer that I'm talking about is something that that I actually wrote. We open sourced it, so you can find it as well and start using that. And there's others that did similar solutions. It's not actually a lot of code that you need for this. All right, so we are getting closer to automation because, well, at least we can start deployments now. Our load balancer will automatically pick up new backends that we start running. We have this virtual networking already, so that's good. But if we now auto-deploy, how do we make sure that we don't cause any downtime? Because, well, downtime is always bad. So one of the approaches to avoid downtime while doing deployments is to deploy in a blue-green setup. So blue-green means that every time we do a deployment, we will scale up a completely new cluster, right? So we will basically spin up new containers because, well, we are in a containerized world, while the old application is still running. And all the load being used by customers is still on the old version. So we're spinning up a new cluster, and we start monitoring that cluster for it to become healthy. Well, we all know if you do a deployment and you're deploying Java, for example, it might take a little while, maybe a few minutes even, before the application is completely started up, before you start reading configuration from some external source maybe. Maybe you have to set up databases or whatever. It might take a little while before actually something is running healthy. Maybe even have to do cache warm-ups, etc. So we basically just wait until that new cluster is completely healthy. And we found enough replicas of this healthy application to start using. What we will then do is we will switch the backend or the load balancer to start using this new version of the application. So all the traffic that then flows into my application over HTTP will then start using the other version, the newer version of the application. And if you're happy with that, if things don't start burning and go up in flames, we will probably just start disposing the old cluster because we don't need it anymore. Of course, in most cases, you want to keep it running for a little while because, let's say, the application did get healthy, but as soon as you start to put load on it, it actually starts to crash. You probably want to switch back to the old version again, right? So this is a very proven way to do deployments without downtime, and it's a very safe way. It does give a question though, how do we know a pod is healthy? Well, if you look at Kubernetes, Kubernetes will say it's running as soon as the container is starting. Well, that's not very helpful because my container is starting after a very short period of time, but maybe within my container, my application is still busy starting up, etc. Especially if you're, some of the Java frameworks that you might be using, it just takes a little while for it to, really be started. So we need some kind of mechanism for that. And again, this is not provided by Kubernetes out of the box. This is something that you probably want to write yourself. So the first thing that you want to do is your applications should start supporting health checks. So probably you want to have some kind of health check endpoint in your REST interface maybe that will report back if the application is started successfully or not. And you can use your own, mechanisms there to figure out if you're started correctly. So that's one thing you have to do on the application level. And then we need some kind of component. Again, I put a deployer component there. That's how we name it ourselves. That actually checks this this health endpoints. So looking at the bigger picture, our build server will now not directly talk to the Kubernetes API. Because, if you start talking to the Kubernetes API, that means that the build server would also have to do the health checking, and that might become more problematic. So instead of that, we put a REST interface on in front of that, which we call the deployer. And the build server will just invoke a deployment on this deployer component. Basically just a RESTful interface, and this RESTful interface in the backend talks to, first of all, the Kubernetes API. So this deployer will create a new replication controller in Kubernetes. The next step that it will take is that it will start monitoring the health of all the pods that are started, because we know that we want to, for example, have 10 replicas started up. So it will start monitoring for 10 replicas to actually start up and report that they are healthy. Well, we just provided this /health endpoint, so that's possible, and that's what the deployer should monitor. Once it's found enough replicas that are healthy, it can take care of switching the proxy backend. So we registered all those new pods in the HA proxy configuration, and we can just switch the backend completely in HA proxy, well, by flicking the switch basically from the deployer. So again, we have one component that just takes care of the ID of deployments, and it talks to all the other components to actually make that happen. Because this is not something provided out of the box. And if we look at the way we do things ourselves, we use our own deployment descriptor basically that kind of configures this. So this is what we write on our build servers to start deployments. We can specify that we do want to use this health check mechanism. You might want to turn it off if you didn't actually implement that. We can provide some variables if we want to. We can specify the replicas that we want, the number of replicas. And we have this front-end property that says that this is the front-end in HA proxy that we are talking about. So this is the application that we are actually trying to deploy. And then in the pod spec section, this is coming directly from Kubernetes. So that's the place where you actually specify the image, the ports that you want to open, and all the environment variables that you want to pass to the container. So this way we have our own mechanism to completely automate this deployment, including a blue-green scenario. And there's nothing you have to do by hand, basically. You just start a Bamboo build, and that's it. So let's see how that actually looks in practice if you run all of this. I have an application here, and you can see it's running at release 83. And we're going to deploy a new version of that, so we have a Bamboo deployment plan. The first step is that we build a Docker image from the build that we just did. So this is actually deploying a Java application. We push this image to our registry, and here we see that we have a script, which is basically just a curl, which sets a new version to the new Bamboo build version. And we have this JSON specification that I just showed on the slide as well. So that's basically it. On the build server, I can then just trigger a deploy to a given environment. And I choose to create a completely new release. So that's where you can work with different releases in Bamboo as well. And you can see it will start building the Docker image, start pushing the Docker image. And at the end of the step, it will do the curl to the deployer, which actually runs in the Kubernetes cluster. That's running there. And we can see that it's creating a bunch of stuff. So it's creating a proxy configuration, it's creating the replication controller. And if you look at the Kubernetes master, just to give an idea if the pods are running, we see that we have pods running for both version 83 and 84. So currently, if you would go in the browser, you would still see version 83. Because the new version is still starting up. And here you see the health checking in action, so you see some logging there. And once the application becomes healthy, you saw that it actually switched the load balancer configuration to the new version. And if you now refresh in the browser, we're on release 84. So that's at least nicely automated. The better thing about this is that there's no downtime at all during a version upgrade like this. We have literally done tests with thousands of concurrent users hitting the application, just using tools like Gatling, and no connections were dropped at all. So, that's really nice. There's one thing you have to get in place, and that's this only works if your application itself is stateless. If you're using HTTP sessions, well, then good luck with this kind of approach, because that's just not going to work. If you use HTTP sessions, you have another problem already, because if I talk about, well, you might want to run 10 different replicas of your container, well, that's already a problem if you're using HTTP sessions. So if you want to this kind of very dynamic deployment approaches, don't use HTTP session. And sure, there are ways to work around that, but you make your life very difficult if you rely on that. So don't. All right, so we have our application running. We can deploy it completely automated. That's nice. And now I break something. Where do I start looking? Well, in the old days, it was really nice to debug problems because, well, I had one server. So what would I do? I would just SSH to this server, find a log file of my application server, and start digging into there. Great. Now I might have 50 different pods running on 20 different machines. I don't really know which machines are used, and I don't know the stack trace that someone emailed to me from his browser, which pod actually generated that stack trace. So there's really not really a way I can just SSH into a machine and find any kind of useful logging. That's just not how things work anymore. You don't want to know where your stuff is running. You just know it's running in the cluster, and that's it. So there's a tool, kubectl logs, that you can actually use to gather Docker logs, basically, of a running container. But that kind of implies that you know which pod is actually the pod that you're interested in. So that's just not going to work. So if we want to start using this stuff in a more reliable production way, we need centralized logging. That's key. That's probably the first thing you should get into to get working. Luckily, there's a lot of useful tools for that, like the elk stack and Greylog. Greylog is the thing that we use ourselves, and it basically means that you configure all your Docker containers, your applications in such a way that they all log to a central logging facility. And that will give you dashboards like this. Doesn't matter which tools you use, as long as you get this kind of logging working before you start using this kind of stuff in production, because otherwise it will be very, very difficult to chase down problems. So, last step. We might want to configure our containers. Let's say we have an application that uses a database. Well, which database? What's the username of the database, and what's the URL of the database? And that's probably different from in the different environments that we use. If you use your container on your development machine, you probably want to use a different database than in production. There is actually a few simple ways to deal with this. So one very simple but very effective approach is to just use environment variables. If you've used Docker for a while, you probably know that you can just pass in environment variables to a container with a -e parameter. Well, Kubernetes supports the same thing. So in the pod specification, you have an environment section, which is basically just key values, and those key values will be passed into your container. And in the container, you can just have some code that picks that up and uses it in wherever you want. So that basically means that your configuration files that you use, this is some configuration file format that we use a lot, even could or actually will have some kind of parameters. So this Mongo variable is actually a parameter provided as a environment variable to Kubernetes. And that way you can very easily pass in configuration to the container. If you want to go a little bit more fancy, you could store your configuration in something like etcd. Again, we have this key value store already. Why not use it? So the only configuration that we really need in the application itself is the address to where etcd is located. And in etcd, we create basically a directory for my application that we have here. and in that directory we just pass in JSON as the body, and that will contain all the configuration parameters that we have. Of course, the application should have some kind of way to read this from etcd, but you will find all kind of tools and libraries to do that for you. So that's another nice approach. The nice thing about this is that it at least opens up the possibility to start doing dynamic configuration updates. I'm not saying that's always a good idea, but it can be useful, and it can easily be done based on this approach. Right, so we've seen the different steps that we need to get to production, and what should you learn from all this? Well, first of all, Docker and Kubernetes are awesome. And especially if you are talking about bringing this stuff to production, these are the tools that you want to be looking at. Although they're also awesome, they're also just building blocks. It's not some kind of magic thing that you open up from a box and, well, solves every possible problem for you. They're building blocks. And that means you should get familiar with the API and start using the API. There's APIs for Java as well, APIs for many other languages as well. So, and of course you can just use the REST API directly. So there's plenty of options there. Then of course there's the product that I'm actually building and trying to sell, which is called the Cloud RTI, and that's basically a completely managed environment in a way, well, as described here. Of course it's much more fun to do it yourself, so I would recommend that if you're into that. And with that, we're at the end of the talk. Thank you all for listening, and if you have any questions, now is the time.